We will conclude this section with two examples. So example 6 shows the direction field for dy dx equals 2x plus y. We're asked to sketch the solution curve that passes through 0, negative 2. From this sketch, write the equation for the solution. Okay, so first of all, let's locate 0, negative 2. The direction marker has a slope that's negative, so the solution is going down. Now, we don't know if it keeps going down in that direction or if it might bend off a little bit. You see the direction marker here has a slightly less negative slope, and so you might think, okay, my solution does this, right? Goes down steep and then eventually is almost horizontal and then goes up. Now, let's try to be a little bit more precise about this. So let's think about our differential equation, dy dx equals 2x plus y. So if we look at dy dx at 0, negative 2, then that is equal to 2 times 0 plus negative 2. And so that's negative 2. So the slope, this is the slope of the solution. And that seems to agree with the little direction marker we see over here. Now, let's take a look at the isocline. For c equals negative 2. So remember, we're going to take a look at f of x equals c, so f of x comma y equals negative 2, and then c equals negative 2 here, and our xy, f of xy is 2x plus y equals negative 2. Now, when we solve that for y, we get y equals negative 2x minus 2. And what we notice then is that the slope of the isocline is negative 2. Right? That's this negative 2 here. So we see that the slope of the solution equals the slope of the isocline, and in that special case we actually know that the isocline, negative 2x minus 2, is a solution to the equation, to the differential equation. So our solution here is actually a straight line. And so if we go here, we actually see that if you draw that straight line, it matches up with the other little direction markers. You see they match up perfectly there. And so this right here is our solution to or through 0, negative 2, and then the equation for the solution is the solution of the isocline. So right here. So that is the solution of our differential equation with initial condition 0, negative 2. Now let's take a look at sketching the solution curve that passes through negative 1, 3. So negative 1, 3 is right here. And we see that our solution is curving slightly upward. And if we continue that, we see that our solution is probably doing something like this. So it's curving down, then somewhere over here there might be a slope of 0, and then it curves back up. So again, I can't do this with a tablet, so I'm going to cheat a little bit and import a picture that I drew by hand before. So what you get here, let me see if I can kind of match it up. Right? So here's our solution still, our original solution, and then a solution through negative 1, 3 starts here, goes up, forward for positive, for x getting larger, and if x gets smaller, then it looks like that. So that's the solution curve that passes through negative 1, 3. So then part C asks, what can you say about the solution in part B as x goes to infinity? So when x goes to infinity to the right, our y goes off to infinity as well. So let's put that in here. So as x goes to infinity, we have that y goes to positive infinity. And when x goes to negative infinity, we also see that the y values get larger and larger. So in that case, y goes to positive infinity as well. Okay, the next example, we want to draw the isoclines with their direction markers for the differential equation dy dx equals negative xy, and sketch the solution that satisfies the initial condition y of 0 equals 4. Okay, so for the isoclines, we set f of xy equal to c, right? We look at where the derivative or the slope is equal to c, the slope of the solution. So f of xy in this case is negative x over y equals c. Okay, now if you multiply both sides times y, then you get negative x equals c times y. And of course, y cannot be equal to 0. That's something to note. Because otherwise we would have division by 0. So when we look at the solution, any solution would avoid the line y equals 0 or the x-axis. Okay, now another thing to keep in mind is what happens when c equals 0. So there's a special case here because we want to solve for y, and so I want to divide by c. But if c is 0, so if c equals 0, then the right-hand side becomes 0, and then we have negative x equals 0, or just x equals 0. So if c is 0, then the isocline is the line x equals 0. So let's put in that isocline here. So x equals 0, that's the y-axis. So let's put that in here. Over here, and then we're going down here. So that right there, this is the isocline for c equals 0. Okay, now let's continue and see what happens if c is not equal to 0. Then we can divide both sides by c, and we get negative 1 over c times x equals y. Or that's equivalent, of course, with y equals negative 1 over cx plus 0. Again, this is a straight line, so the isoclines are straight lines, and the slope of the isocline so this is the slope of the isocline is negative 1 over c. And I'm going to look at two examples. So when c equals negative 1, the slope of the isocline is negative 1 over negative 1, and so that's 1. So we have a line here with slope 1 and y-intercept 0. So this is the isocline that corresponds with c equals negative 1. Now remember, that means the slope of the solution. And then when c is 1, the slope of the isocline is negative 1 over 1, and so that's negative 1. So c equals 1, that means the slope of the solution equals 1. And for clarity, I will add to this that the slope of the isocline is negative 1 over negative 1. That equals 1. And here the slope of the isocline is negative 1 over 1, and that's negative 1. So you have a line with slope negative 1. So let's put in some of the direction markers. So c equals 0. That means the slope of the solution is 0. The direction markers look as follows. They look as like this. They're just little straight line segments. Oops. So here, let's put a couple of those. So I hope you get the picture here for this isocline where C is 0. Now let's take a look at isocline where C equals 1. So C equals 1, that means we have a little line segment that has slope 1. So something like this. And I should make these a little bit smaller, but again, I hope you get the idea here. So those are the direction markers when C equals 1. These are little line segments with slope 1. And then finally, we have C equals -1, so the slope of the solution is -1. Our direction markers then look like this. And so if you had a little bit more time, you could do other values of C. For instance, C equals 2. Then the slope of the isocline would be -1/2. So it would be a line that would go like this, right? So the isocline would look like that. And then the slope of those little direction markers would be 2. So now all we have to do is to sketch the solution that satisfies the initial condition y of 0 equals 4. So if we go to the computer generated direction field here, we start at 0, 4, and then according to the direction marker we start off kind of horizontal, but then our slope gets more and more negative. And so we go down here until we reach the x-axis. And what we draw there, actually, you can show that that's part of a circle. So again, I'm going to cheat here and copy this image that I drew before. Scale it down. And put it over here. So our solution here is part of a circle.